pilot taking care of me. Stewardess, go. Okay. Okay. So if you can find your notes from yesterday, I want to finish off this problem. This problem was big time hard for where we were yesterday.
Okay, you can't really see it.
But here's what I really care about. I care about the big picture. The fact that we're 2/3 of the way through this problem and we're not done. We filled up a whole page is part of what makes these optimization problems so darn hard. There's so many mistakes you can make and it just sinks the ship and things go badly. So I'm not expecting perfection, especially on a problem like this. What I do want you to do though is just take a minute, take 2 minutes. Look over the work that we did yesterday. Get your head wrapped around this. Where were we? Where did we start? What's the next step? If you're sitting next to Anthony, if you're sitting next to Jennifer, if you could maybe kind of get them caught up so that we can finish this problem strong, and then we have a lot more practice coming today. But go back to the beginning, go back to the beginning. Why did we set it up this way? Where did these equations come from?
Objective and constraint.
Yes. But did you get the same answer of 6? But instead of 1.8, you get 0.8? You're fine. Right, we used the Pythagorean theorem to come up with that equation. Okay, we're going a little crazy.
Okay.
Focus on your conversation with Nora. Look at Nora. She's so lost, she's playing with her hair. She's not having conversation about calculus. Can't close the achievement gap that way. Jose, thank you so much.
We're talking about what we did yesterday.
And yesterday, we paid attention to lesson 15. And both yesterday. So we're not part of the video. You're part of the
Yeah. Okay. All right. So yesterday, when last we were looking at this problem, we set up our semicircle, we set up the rectangle, we had, what's the name of this first equation? Noemi didn't capture it in our notes. This a equals 2xy, this is the...
Objective.
This guy here is the, one more time?
Objective.
It's the objective function. The objective function is the thing that you're trying to make really, really big or really, really small. Noemi did capture in her notes that x squared plus y squared equals 16, which we called the constraint. It's the thing that relates your variables together, but you only ever take the derivative of the objective function, not the constraint. The constraint is what links your variables together. We went through, we solved the constraint equation for y. Somebody else could solve it for x, it doesn't matter. You rewrite the objective function in terms of one variable so that you can, what?
Evaluate.
Not evaluate, that's actually not the step that you're on at this point.
Okay.
internal.
So that you can find the derivative, so you can get to, what was the word, Jose? You can get to my internals? No. You can get to the internal candidates, is that what you said? Didn't sound like endpoints to me, yeah. Right, you find the derivative, you set the derivative equal to 0, you figure out where it's undefined to get the internal candidates. On this problem, the endpoints were relatively easy. I think we just knew that they were 0 and 4. And if all is well, so where were we at? We've got endpoints, and this is where you should be picking up your notes. Your endpoints are 0 and 4. Those internal candidates. Looks to me like Noemi's got in her notes x equals plus or minus the square root of 8. And was that it?
We had x equals plus or minus 4, but we canceled it out because it's...
Okay, so, all right. If your internal candidates are x equals plus or minus the square root of 8, x equals plus or minus 4, how many internal candidates?
Only 1.
I heard 1, 4, 1. How many internal candidates inside the interval that we're interested in?
1.
It should just be 1. I'm not going to consider the negatives. I'm not going to consider 4 because 4 is the fancy word for that again?
And
What's the word for that? X equals 4 is, it's an endpoint. It's an endpoint of the problem, so it's not technically inside. So I think the only thing we actually didn't do yesterday was that last step, which is the evaluate step. So I want you guys to just take a moment, finish this problem off. We've got our endpoints, we've got our candidates, Jennifer and Anthony, whoever you're sitting next to, they're going to help you out. And I want to go back, if I'm going to evaluate, Rambir, which function are we going to evaluate?
You're going to put it back into the original equation.
Go back into this original one over here?
Yes, go with it after you plug it in.
Right, if you go back to this one, all you have is the x, but you don't have the y. You probably want to do your evaluation over here. Nora, on this problem, are we looking for a max or a min? What did it say in the beginning? It said largest, so I'm looking for max. Okay, so finish it off. I'm going to finish it off, but you guys finish it off on your own. Don't look up. Don't cheat. You don't need me. I just get paid to hang out with y'all. So you just did all this in the brain. Hopefully 2 of these 3 answers are not a surprise to anybody. Right, if my x value is equal to 0, my rectangle has no width, it's all height. And if x is equal to 4, then it's kind of built like me, it's all width, not much height. Okay, that was funny. And then if x equals the square root of 8, that seems to be the, oh, okay. If x is the square root of 8, that's the just right spot. That's the maximum. Is everybody mostly okay with finishing this off? All right, good. So, close the book on that. This one's done. The homework this weekend is going to involve a problem like this. You've got a great model to look at. Here's what I want to do in the course of the next. Sadly, we only have 36 minutes. Somebody has taken my time away from me. I want to go through 2 more model problems. That's on the handout that you guys picked up. The homework this weekend is to do 3 of these problems. You're going to do them from start to finish. 2 of them should be very comfortable. 1 is going to push you. Hopefully your hair won't fall out. What I want you to do is, I'm going to give you guys the first 5 minutes, working with your partners here, to do this first model problem. It's the one about the pea patch. This one that you guys are going to do right now is the first problem I did with the BC class, and this is where I broke them. I didn't bend them, I didn't push them, I snapped them in half. I want to give you guys the first 5 minutes working at your tables. Show me what you can do. Whoever's birthday is closest to Christmas is in control of the cups. If you're not sure, Christmas is December 25th. Another great opportunity to buy things for your teacher. I don't want a coffee cup. Just saying. No teacher actually wants a coffee cup. Okay, 5 minutes. Go for it. Keep your apples at home. When you think you've got the objective and the constraint, call me on over.
I think you can read out loud too.
Yeah, you could also just read it to yourself on your attack.
Square meter rectangle. Divided into quadrants.
How much
So there's fence all around it, right?
And then there's fence.
does that sound right?
I don't know.
The whole is a rectangle and then divided into squares.
Looking good. We've got some strong starts.
You put a rectangle by half, it's a square, right?
So we already know what the heck
So they're all X's. That's right. There's like... It's a diagram.
Not up to size.
Okay, keep going.
Oh, I didn't do it like that. Does it make sense? I think I'm just complicated. I'm looking at this, that's why.
I'm broken.
No, you can't possibly be broken. It takes more time to break it than that.
What does it mean, outer rectangle? 2W times 2L.
If anybody's not sure what this pea patch looks like, this is what it could look like.
Beep back.
Right? You start with a rectangle and then you've got another fence that you're putting in to divide it into two equal pieces. Now I saw in Anthony's paper, I saw Anthony made his rectangle that way and put the fence that way. Is that okay? Yes, it is absolutely 100% okay. You can label this any way you want. If you're like, this is L and this is W, great. If you say this is L and that's W, great. Most folks have already figured out, you've got 216 square meters, that represents area. So either way, you're going to say A equals L times W. The place that you want to be careful, though, is the fencing. Where does the fencing go? All the way around?
And
the middle.
And the middle piece. And the middle piece. So if I'm going with this idea, my fencing equation is going to look like L, right? L, W, another L and another W,
And another W.
and then another W. So your fencing equation is going to be F equals 2L plus 3W. For Anthony and his crew, he's going to say, well, the area is length times width, so my fencing equation says L, 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 W, W, 3L plus 2W. Both groups, 100% okay. 100% okay. And this guy is the, which one?
Objective function.
It's either the objective or the constraint.
Constraint.
This guy here.
The objective.
That's the objective function. This is the thing that you want to take the derivative of. This guy's the constraint. This is what connects your variables together. In fact, it shouldn't be F, right? Oh, my bad. So awkward, and that was on film. Dang.
Feel bad for you.
Well, I'll have to record the next class instead so I can look smarter. So the 216 equals L times W is,
The area.
it's the area, constraint or objective?
Objective.
Constraint or objective?
Objective.
No, but we're solving for this.
You had told me.
Constraint.
Isn't it the constraint?
This guy is the constraint. Because this is the one that tells you what the constraints are on your length and your width. This guy here is the constraint. My apologies to everyone at Yes Prep that I just confused. That wasn't the intention. Okay, optimization. Now, I didn't see anybody do it, but if you know that you're going to divide the rectangle into two pieces of equal area, you could have said, well, let me call this guy over here L, let me call this guy over here W, and the area for this piece, if they're going to be equal, it's half of 216, which is 108. And so there might be somebody in the room working with L times W equals 108, but then you've got to be careful with your fencing equation, because your fencing still has to go all the way around. Your fencing then, you've got an L, and an L, and an L, and an L, plus a width, and a width. All three options, totally valid. Totally gonna work, just don't blow it. I'm curious, how many guys set up your diagram this way? How many else set it up this way? I know Anthony did. Anybody else? Okay, Anthony and friends. Did anybody set it up this way? Okay, good. Finish it off. Keep going. We'll talk in a few more minutes.
You subtract 3W, right? Or 2L. What did we solve for yesterday?
I mean, it was his fault here.
So then we subtract
I
L.
don't know how to talk. He said it was very Myers said,
One of
I don't know how
the
to talk. Okay, so, and I just gotta make that initial connection.
Okay.
That's what I was.
Bye-bye.
That's like every part.
What's the optimization?
I should have said all that.
So the optimization or the objective function is what you're trying to make as big as possible. That's the thing you're trying to maximize.
Ooh, are we gonna find?
Okay. And that's why you always need a constraint.
But then there's F.
Whichever area
When you do the
was
constraint, you subtract
F is just one
No,
thing.
no, the equation itself is the constraint.
But we normally
The equation is the constraint.
put it equal.
Right, I gave you area information, so you're constrained.
We normally put that equal to like the amount of fencing. So it doesn't need something as for fencing. So you're giving us the area. So now it's gonna be.
No, we just plug it in. Plug it into the equation. Wait, no, I think it's. Let me see the one.
Right, you're gonna find the derivative. Now, you get F, that over W.
We got your equation, so we put that for
Both,
we found what L was.
you're just, it's gonna look a little bit different, but you're ultimately gonna get to the same place.
No, we did wrong.
either way, this is being originally
Oh, okay, I get it.
What is F?
Giselle, can you turn the camera so you capture what I'm writing over here?
Yes.
Uh-huh.
F is supposed to be 216, correct?
F?
No, that's fencing.
No, that's the area. That 216 is the area of the P patch.
Right, I'm saying that for F.
F is not 216. F is what you're trying to make small. The 216 is what relates your length and width together. This is the constraint. So F is going to be 2 times 216 over W plus 3W.
Give me that.
I multiplied 2 and 216.
-1. Wait, what?
I don't know, you're solving it different. I'm solving it like he.
Okay, so you found the other one and you plugged it in for L, right? You
Right,
for L.
because that's what you do with the constraint. You've got to get your objective function to be in one variable. So if you know f equals 432 over w plus 3w, now you've got to go find the derivative. One option to find the derivative,
Quotient rule.
maybe do a little quotient rule. Another option is the kid that says, wait, isn't this really the same thing as 432 w to the negative 1 plus 3w? And now you do your power rule. Either way, what you're going to get is negative 432 over w squared plus 3. That's the derivative. Daisy, assuming that you're okay with finding the derivative, what's your next move?
You get the candidates
Okay, and you're going to get the candidates how?
by
There's two things here, right? What's the first thing?
You're gonna set it equal to 0.
We're going to set that derivative equal to 0. So negative 432 over w squared plus 3 is equal to 0. The second thing, Daisy?
And then you set the denominator equal to 0.
Because what we're looking for is where does the derivative not exist? So where would negative 432 over w squared plus 3, where would that not exist? What has to happen for this to not exist, Martyr? What has to happen? The denominator has to be equal to 0, so w squared is equal to 0, so w is equal to 0. Over here on this side, I'm going to use my fraction killer powers. I'm going to multiply everything through by w squared to get negative 432 plus 3w squared is equal to 0. A little bit of algebra is going to go a long way. 3w squared is 432. Divide by 3, so w squared is 144. W is going to be plus or minus the square root of 144. And all my folks that survived 6th grade know that the square root of 144 is 12. So W equals plus or minus 12. On your fingers real quick, how many internal candidates do you see? How many?
Oh.
1, 2, looks like 2, looks like 1, looks like 2. Christian's giving me the finger again. Okay. 1. No one's going with 3. Is it? No one's going to pick negative 12? Negative 12 doesn't make sense. Get rid of it. Does W equals 0 make sense?
It's an endpoint.
It's an endpoint, maybe. Maybe. Okay, what I hope everyone's at least comfortable with is we've got internal candidate for sure. The internal candidate for sure is that W is equal to 12. The one that maybe we're like, I don't really know, is going to be the 0. Your next move after this, you're going to go and plug everything in. You're going to plug into the original fencing equation, or this version, any version that you want to. There is one thing, though, that makes this problem special, and I want to make sure I get all your brains on this. It's the fact, it's the endpoints are the problem here. We're going to run into a problem with the endpoints. The original constraint is this 216 equals L times W. What is the smallest that the width could be? This is the question to ask yourself when it comes to endpoints. What's the smallest it could be? If you say 0, look at your constraint. Your constraint says 216 has to be your length times your width. Can the width be 0?
No.
No, because then you don't satisfy the constraint.
Yeah.
So 0 is not actually an endpoint this time. You can't use 0. What's the smallest thing you can use?
1.
You were all going to say that.
0.1111.
I think what you meant was point like 0.00001.
Yeah.
Not 1, because the folks that say 1, they forget that there's all these numbers between 0 and 1 that have decimals. So if I'm thinking on a number line here, at 0, I can't use 0. I'm going to indicate that with my parentheses. This is no longer a closed interval. It's open. And the fact that this is an open interval changes everything for us. If we're thinking about W, is everybody okay? We can't use 0. Clearly not going to use anything smaller than 0. What's the biggest thing I can use for W?
216.
I knew that was coming. 215.999. I heard 216. 72. Didn't see that coming. 58.
216 divided by 3.
Could one side be 432 meters?
Yes. If the other one's
Yeah.
2 point something.
If the other one is a really small number. Again, you guys have your blinders on. You're thinking whole numbers all the time. So what's the largest that the width could be?
Whatever it wants.
It can be whatever it wants to be. I'm not bounded by 216. I need the product. I know, you're like, that's 2 for 2. The width can be as big as I want it to be. The width could be as small as 0, or it could be all the way out here at positive infinity. And I'm putting this all on a number line for a reason, because we have no endpoints to plug in. We are stuck. You cannot finish this problem unless you do the one thing left in your arsenal, which is to use the number line test. Because we don't have endpoints. Yesterday, when we had to use the number line test, we did, or no, 2 days ago, we did the number line test because when you plugged in the endpoints, you got ugly numbers. Remember, it was like 3 over e and like natural log of 3 over whatever, and we didn't know those values. We're back to the number line test because I don't have endpoints. So what I'm going to do, pick a test value. I need a good test value between 0 and 12. How about 1? And I'm going to plug my test value into the derivative. At w equals 1, f prime is negative 432 over 1 squared plus 3. The only thing I care about, take a couple seconds and think about this, is that value positive or negative? This has to be negative. 1 squared is 1, negative 4, are you okay there? Negative 432 over 1 is negative 432 plus 3 is negative. So I've got negative values for my derivative over here. Pick a value over here. I see you. Hold on. If I pick something like, I don't know, 20, then f prime is going to be negative 432 over 20 squared plus 3. And I picked 20 because you guys should know what 20 squared is. 20 squared.
400. No.
Oh God. 20 squared is 400. Negative 432 divided by 400. I don't expect an exact answer.
It'll still be positive.
No.
No.
It's going to be like negative 1 and some stuff. Negative 1 and some stuff plus 3 must be
Positive.
positive. So look what happens with your derivative. At w equals 12, f prime changes from negative to positive. So this has to be. At w equals 12, f prime just changed from negative to positive. So what do we know about f?
It's a minimum.
F prime just changed from negative to positive.
Oh, it's a
Minimum.
So f just changed from decreasing to increasing. Fancy word for that? Minimum, but be careful.
Relative.
F has a relative minimum. Okay, now, BC Kids Row, he's like, oh, thank God I'm done. The question asked for least. I've got a relative minimum. Don't get these things confused. A relative minimum isn't least. A relative minimum isn't absolute minimum. Yeah.
But what about the endpoints? Isn't it like absolute? It has to have like.
With absolute extrema, there's normally endpoints. But what does this graph do? Whatever this graph does, the graph of f decreases and then increases. Does it do anything else? After 12, does it turn around and decrease again? Before 12, is it suddenly increasing then decreasing? No, your graph looks something like this. And if I showed you guys a graph that looks something like this, you wouldn't call 12 just a relative minimum. Wouldn't you say absolute minimum? But here's the conclusion. Here's the part worth paying attention to. You're going to have to end this with, since this is the only relative extrema, this implies it is, oh my God, it? Oh, I know!
Oh, I'm dying.
Okay, I'll take a 300. W equals 12 is the absolute minimum. The key is you have to do the number line test because you have no endpoints. You have no choice. You can't plug in 0 and infinity. You have to go to the number line test. But the number line test can only give you relative min, relative max. It cannot give you anything more. No options there. But if you consider the behavior of the graph, my graph decreases, then it increases. That relative min is also the absolute min. What do you mean?
So if we don't have the graph, how are we gonna know?
That's why you do the number line test. Because the number line test, you can use this to test the signs and tell me how the graph's behaving, even if you don't see it. We're good? Everybody mostly okay? All right, so we've got about 15 minutes left. We're going to split the group. 3 options. Group number 1, Anthony and Jennifer should go into this group. I want you guys to look at the notes from yesterday, work on some of the problems that we did yesterday. Rather than you two doing tonight's homework, I want you to do what everybody did last night for homework. Does that work for the two of you? Why don't the two of you maybe move back to where Jennifer, Jasmine, and Martyr are? Okay. You guys are group 1. Anybody want to work with them, maybe help them out on what they missed yesterday? Nobody wants to help. Adriana, you're willing to help them? Okay. So Adriana and Jennifer are going to work with Jennifer and Anthony. Why don't you guys go over there? Group 2. You are hungry for a challenge. You want to go further with this conversation on optimization. Okay, you want to see how high the ceiling is. That's the group that's with me. Where are those folks? Wait, I'm trying to count all of you all. Okay, I see Giselle. Just me and Giselle and Rambir.
We didn't even answer this question.
We didn't?
No.
Okay, hold on, let me finish dividing up the groups here. Just me, Giselle, and Rambir? No, I think other people are going to come. I think Eunice is going to come. I think Kimberly's going to come. I think Nora's going to come. I think Christian's going to come. I think Jonathan's going to come. You really want to do this. It's going to be really good. Because what group 3 is going to do is they're going to get started on their homework. So that you get a really good, strong start. Group 2, the folks that want to go for the hard stuff, you're over here.
We needed help.
Group 2's over here, Group 3 we're in the middle, Group 1 over on the side. Jennifer, 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 and another Jennifer, I think.
There's no option for help.
The Group 3 is kind of like you're helping one another out. But you should be in Group 2. 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 Jonathan should be in Group 2. Martia, where are you going? You look lost.
Do I stop it?
I mean Marvin.
Do I stop it?
Group 2's over there. No, keep going.
Okay.
All right, Group 2. 3. Okay. So how much math do you need? W is 12. Go find the L. There you go. Group 2, we're going to do a really hard problem. Okay. So Martyr, you're in Group 2. Group 1's in the back. Group 3, we're kind of here in the middle. You've got the camera. Kimberly, you're over here. David, Noemi, Abraham, you guys are in Group 3. Okay, move the camera over here. You guys read this problem. I want to get started. We're not going to finish it. It is not possible we're going to finish it in 10 minutes. But that's okay. We're going to have some fun anyway. You're with me in group 2, right? And you're in group 2. But you're in group 3 working on homework. Why don't you sit back here? There's room back here. So give it a read, mark it up. What are the things you know? Let's go from there.
I know.
It is very likely that your geometry might be a little bit rusty. So, friends in group 2, what do we know about this problem? It says a right circular cylinder, but really that just means
Cylinder.
a cylinder. It means a can, right? So draw a can. Now, there's something special about the can.
Has no top.
No top. No top to this can. All right, what else? Christian, what else you got?
The surface area.
Okay, tell me about the surface area.
It's 300 pi.
300 pi feet squared. So already I know whether this is the constraint or the objective function. Which one is it, Jonathan? Constraint or objective function? It has to be the constraint. Whatever you're going to build for me, it has to have a surface area of 300. The objective function is the thing that I'm trying to make really, really big or really, really small. What am I trying to make really big or really small? Volume. So volume, now here's where you might be like, Coach, I don't remember any of my formulas here. I started with something nice, a cylinder. We should know the volume of a cylinder. Right, you might remember this as V equals big B times H, where the B represents the base area, so the volume is pi r squared times the height. Okay, great. This is the thing I want to take the derivative of. Giselle, what's going to be the problem here?
There are two variables.
There's two variables, can't take the derivative. So I need this constraint. And this is the part I don't think anyone's just going to remember what the formula is. So go back to your can. Surface area. How do we find surface area?
So this constraint. Someone's constraint. Check out this.
Circular, okay? So that's what you're saying. This, my middle finger, the entire length of this. When I open it,
All right.
this is my circumference.
So surface area. The idea with surface area, like if you were going to paint this can, where would you have to use paint? You'd have to use the paint on the bottom. And how much paint there? That bottom part, that's just a circle.
Area.
So it's area of a circle, so it's pi r squared.
Why is that multiplied?
The tough part usually is the part going around the outside of the can. But if you picture like a soup can, right? Cut that label on the soup can, lay it flat. What do you really get?
Rectangle.
You get a rectangle. How long is the rectangle?
Length times.
Right, that label goes all the way around the can. That's the circumference of the can. So it's going to be pi r squared plus 2 pi r times h. So I've got pi r squared plus 2 pi r h plus another pi r squared.
So what am I finding the derivative?
Because it doesn't have
There's no top. Don't make it 2 pi r squared. There's no top. And all of this then has to be equal to 300 pi, which is your constraint still. What's the strategy from here? Watch here, what's the strategy? What are you going to do from here? I've got a constraint. I've got the objective function. What are you going to do? I want to find the derivative of the objective function to figure out when it's as big as possible, but there's a problem.
There's two variables.
I've got two variables. I'm still stuck. So you're going to go over to this guy over here and solve for one of the variables.
That's what you did over
Now,
there.
let's be clever about this.
Oh, yeah.
Marvin, do you want to solve for R or do you want to solve for H?
Oh, they moved it right.
You're a young adult. You can solve for anything that you want to, but your options are solve for R, which shows up here and here, or solve for H. Given a choice, what do you want to do? You want to solve for R. So not what I thought I was setting you guys up to say. Wouldn't H be easier?
Yeah.
H shows up here and only here. So solve for H. So I've got pi r squared plus 2 pi rh equals 300 pi. So 2 pi rh is going to be 300 pi minus pi r squared. I still haven't solved for h. I want to.
What did he
Divide
ask?
all of that by 2
So I can
pi r.
divide everything by 2 pi r.
Multiplying the whole square?
So h is 300 pi
Where you at?
minus pi r squared
I found the derivative.
over 2
and
pi
now I'm trying to
r.
solve
This
it.
is not the kind of problem I'm going to put on the quiz next week. We're going for bonus in these. Okay? Jonathan, why did we solve for h? What are we going to do?
Is that W squared?
Wait, you're gonna do what? We're gonna plug this back into the objective function. So instead of saying volume equals pi r squared times h, we're gonna say it's pi r squared 300 pi minus pi r squared over 2 pi r. And you've got some choices to make now. I've got my function in one variable. Life is good. It's one variable. But if I'm going to go take a derivative, which is the next step, Giselle, what derivative rules are you going to need?
Quotient rule,
You're going to need a quotient rule the way you've got it set up. Anything else?
product rule.
Maybe you need to have a product rule, or do some algebra.
Plug that in.
Right? You can always do algebra before calculus if it's going to make your life better. Anybody see any good algebra? Any good algebra?
Plug it in.
What do you say?
Can we already like simplify where we got h? Could we simplify that?
You want
Like
to simplify
that?
in here?
Could we?
How?
I mean, you could cross out pi.
Now I want to be careful because you guys often like to just cancel out things. You're like, oh, it shows up in the top, it shows up in the bottom. Oh, I see. You can only cancel out factors.
Okay.
So I see a pi in the denominator, that's a factor. Is pi a factor in the numerator? Can I factor out a pi from both terms?
Yeah. Yeah.
Yes, I can. So this pi will cancel out both of those. So now I've got volume equals pi r squared times 300 minus r squared over 2r, and that's good. That's good. You might say, hey, you know what? I just want to go take a derivative. You could also multiply through. Pi r squared times 300 means 300 pi r squared. Pi r squared times r squared means pi r to the fourth over 2r. I got a quotient rule. I'm good with quotient rule. I could also say that this is the same as 300 pi r squared over 2r minus pi r to the fourth over 2r. And the reason that I did that, hold on, rather than one fraction where I need the quotient rule, I've got an r in the numerator and an r in the denominator that I can cancel out. I've got a 2 and a 300 I can reduce. So I've got 150 pi r minus r cancels out with one of those, pi over 2r cubed. Finding the derivative for this guy should be much, much easier to then solve, finish off the problem. Life is good. I had no intention that we were going to finish this problem off. But but I wanted to get us a good start. The homework this weekend is easier than this, so life will be good. Okay, Jennifer. You guys all good? So the real Jennifer and Anthony, you guys are finishing what they did last. I'm sorry.
So she's like,
You know what you're doing tonight. These guys, hopefully we get a good start on the homework. We'll get it finished off. My group that was over here, you guys went through a much harder problem than anything you're going to see this weekend.